What's the definition of vertical asymptote?
Vertical line.
Value which the function can't be evaluated.
There's more than that. It can't be evaluated. So that's essentially what we're trying to prove. It can't be evaluated, but there's something else about a vertical asymptote. What is it? It gets arbitrarily close. You get arbitrarily close to it, right? If you get arbitrarily close to it, think of it this way. If this is our vertical asymptote, if you were to cross it, you still need to get arbitrarily close to it, so it needs to go back, right?
Oh.
If this happens, what's the problem?
There's a hole.
Not a function anymore. Exactly. So if it were to cross, it would have to come back, and it would automatically violate the vertical line test. It wouldn't be a function. We're talking about functions right now. Can it intersect a horizontal asymptote? What do you think? Absolutely can, actually.
Yeah, because then it wouldn't, you could still cross.
You can still cross and come back.
We just did right there.
Exactly. Here's a horizontal asymptote right here. Happens all the time where it goes up. You can actually cross twice and then go like this.
So it's still
But then-
vertical.
Yep.
So
This
when
is
does it-
still a function. Yes, what?
How would you explain that? Like,
It just does.
Right,
It just
so-
mathematically, it will cross.
but saying from like point whatever that is from the cross on, it doesn't cross it.
No, it does not. Like from this point, at a certain point, it does not cross. That's correct. But can it cross as many times as you want it to? Absolutely. Sure. Sure. Absolutely. Do you want an example? You can make this happens in rational functions all the time. So, for example, you could have, let's say, I'll look one up. I can't make one of these up off the top of my head, but one thing you always have to check, you can't cross a vertical asymptote, but you can cross a horizontal, and you can cross an oblique, which is a slanted asymptote. You can cross either one of those. It's still a function. Can you draw something that looks like that? Yes. Is it possible to have have an equation for any function you can draw? Yes. Hannah, what? Thought the horizontal asymptote was y equals L. How do you figure out where it crosses y equals L? If this is the rational function and you want to know where it equals y equals L, what do you do? Nope.
0 for y.
Nope. Y equals L. How do you find...
So plug in L over L.
Nope.
L over L.
Nope, 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 nope. This is the function. That is the rational function. How do you find out if two things cross? What do you do?
Graph it
You
and
set
then
them
also
equal.
You
graph
set
it.
them equal to each other. You solve this right here. You set p over x, q over x equal to L, and see if it does equal. What happens if it doesn't cross? What happens if you set it equal to L, but it's not actually something that's going to cross? What kind of math would you run into eventually? You'd get to something not weird. You get something that's not true. If you try to say, for example, do these two lines cross? Y equals x plus 2 and y equals x plus 3?
No.
They don't. But let's say we said, hey, we think they intersect, so you set them equal to each other. You get 2 equals 3. Is that true?
No.
No. So therefore, they do not intersect. They do not intersect. If you try to set it equal to some value and it doesn't intersect, eventually you'll get to 7 equals 12 or something that is not true, which means your original assumption is not true, which was that they intersect. Can you cross a horizontal asymptote? Yes. Can you cross a oblique? Yes. Can you cross a vertical? No. Go to lunch. Leading terms here. 2x squared over 2x squared is 1. The other junk is important, but not as x gets really, really big. But not as x gets really, really big. Does that kind of make sense, everybody? So when do you have a horizontal asymptote? This is important. When do you have a horizontal asymptote and when do you not? You have in HA a horizontal asymptote when the degree of the numerator, sorry, I'll say it this way. The degree of the denominator is equal or greater than the degree of the what? The numerator. What happens, so it could be greater than. So for example, I could have, let's say, x squared plus 2x plus 5 all over x cubed. Let's say g of x was that right there. Does that have a horizontal asymptote? It does. As x gets really, really big, what does this get close to? What's the limit as x goes to infinity of g of x? What is it?
Isn't it 2 minus? No.
The x squared one
No,
is
just divide the-
Zero.
It's 0 because the denominator is going to get really, really, really big, and the numerator is not, relatively speaking, right? It's going to be x. It's approaching x squared over x cubed, which is 1 over x, which is going to go to 0. Does that make sense, everybody? So if the degree of the bottom is ever bigger, what's the horizontal asymptote going to be? It's always going to be y equals 0. That's correct. But if the degrees are equal, then you look at the leading coefficients. Then you look at the leading coefficients.
You're reporting.
Looks kind of random, but what is the square root of x squared? Just x. So I'm going to look at the bottom here for a second. So we do this out, and what's the bottom become? 3x minus 5 all over what? What does the numerator become? Well, I'm not going to do the same thing. I do not want to take the square root of x squared. If you have the square root of a over the square root of b, what does that equal? No. What's that equal? What's that equal?
Oh, the
Square root of a over b. So what does this become? The square root of 2x squared plus 1 over x squared. Do you agree with that? What does this equal? This equals 3x over x minus 5 over x, and this equals the square root of 2x squared over x squared plus 1 over x squared. Do you agree with that? Okay. What's 3 over x? What's 3x over x? So this becomes 3 minus 5x, and this becomes the square root of 2 plus 1 over x squared. Right. So have we changed the overall value of the equation? No, we've just rewritten it. And the reason this is really helpful is we're trying to take the limit as x goes to what? X goes to infinity of this thing, right? So why is that really helpful? It's really helpful because just clicking and dragging is not working today. That's okay. It's helpful because what's the limit? What did I just tell you? What is this going to right here? What is, sorry, that one. Let's change colors so it doesn't, so you can actually see it. I got it. What does this go to? Goes to 0, right? What's 1 over a trillion? Pretty close to 0. What's this go to? 0. So what does this come out to be? Done. The limit is root 2 over 3. Not a polynomial. But you're square rooting an x squared, but you're adding something little to it, right? So it kind of looks like, what is this about equal to? It's about equal to what? It looks like that's about equal to what? X. You're doing the square root. It's a little bit more, right? It's about equal. You're subtracting x from x. So maybe this is 0, maybe, but are you sure? Not really. Once again, what's the only thing you're allowed to do to something and have it stay the same value? Multiply by a form of 1. Yeah. So the magical thing here is we're actually going to multiply by a form of 1. And someone brought up the word before that's really important. When you have a fraction, sometimes you multiply by a form of 1, but you multiply by something over something that you call begins with a C, a conjugate. We're going to multiply by, technically, what I would call kind of a conjugate. We want to look at this. This is something minus something else. What do you think that, so if we have this, the square root of x squared plus 1 minus x, like this, we want to multiply it by something. It's going to be a fraction because it has to be something over something else. What do you think we're going to multiply by? Anybody want to guess? This is challenge. This is hard. This is hard.